Okay, good afternoon. Okay, let's start with this exercise. In this one, we are asked to solve for t in the equation given. And if you observe the equation, you see that t is right here as an exponent of the natural base t. So somehow we have to be able to isolate t and bring it down. So first, we manipulate the equation so that we just have this term on one side of the equation. And there are several approaches to that, but what I will be doing here instead is to multiply by r over e both sides of the equation so that this cancels out and those variables transfer to the other side of the equation. So if we multiply by r over e, there we have it. We have just the terms, two terms on the right hand side, and from there we can easily isolate this term. You can transpose one if you want to, so as to make the sign positive. You can transpose this to this side and this one to this side, so that you have this. You just rewrite that, rearrange. So now we have just the only term containing t isolated, okay, on just one side of the equation. So next we try to solve for t by bringing it down. And you know that what you have to use here is a logarithm, and since e appears in the expression, it's natural to use the natural logarithm. So we take the ln of both sides, and then the left-hand side becomes just e to the negative rt over l. Remember that the exponential, the natural exponential and the natural logarithm are inverses. So you just have negative rt over l. And then you can now solve for t by multiplying both sides of the equation by negative l over r. And if you do so, you'll get just sorry, that's supposed to be negative capital L over small r to distinguish it from the capital R there. So you have to do, you have to multiply it to both sides. So you'll get this one. So that gives us t in terms of the other variables, or if you wish, you may want to rewrite that as follows. Negative L over R, ln E minus IR over E. But this one is an acceptable answer. The two are equivalent anyway. So is there any question regarding this one? Here you're going to solve for x. Now note that x is on both the numerator and denominator of the right-hand expression. So applying the natural logarithm or logarithm base 2 will work right away here. But what you can do is manipulate the equation. Yes, I can't hear you. Oh, wait. Okay. Can you speak? Are you asking a question?
Sir, no, you were medyo muffled po kanina. So we didn't hear you po.
Oh, yeah. Am I laggy? Copy?
Not choppy po. Like muffled lang po yung voice mo. Medyo mahina po.
Mahina. Maybe
Pero
the
it's okay.
speaker.
It's okay na po
Now,
ngayon.
right now, okay naman.
Yes po.
Okay. So just tell me, okay, if in case again I'm lagging or maybe you aren't really hearing me. Sometimes think I'm in the province actually. I'm only using that, so that's why we might have difficulty. Okay. Transmitting the session and as well as the recording afterwards. So we will see. Anyway, weather has improved here, so just tell me, okay, if I'm choppy or I'm having or you're having problems hearing me. Okay, we're going to solve for x here. And there are several approaches. Some might try to let, if you actually watch the videos or you join the synchronous sessions, you may already be familiar with this technique. And then you can solve for t first. Maybe let me show both methods. Okay, let's try this one first. So if you denote this by t, okay, the equation becomes like this in t. Just tell me kung paminsan-minsan nawawala ako kahit split second or something ano. Kasi mahirap talaga kapag ganon. Kahit ilang second lang or seconds nawawala. But anyway, you cross multiply. So you'll have this. And you're going to solve for t. So you collect all terms containing t on one side. So left-hand side. It's up to you. But I'll put them all terms containing t on the left-hand side. Then those without t to the other side. And you're going to solve for t there. You can factor out t. And there, you can get t quickly as y plus 1 over y minus 1. But you're not done yet. You're solving for x, actually. So that's 2 to the x. And there are two ways from here to get x. One is by the use of the base there, 2, right away. So take the logarithm of both sides. to base 2. And what happens to the left-hand side? Do the two functions cancel each other out? The first one is an exponential function base 2, the inner one, and then the outer one is a logarithmic function base 2. So that means the left-hand side is just your x, and you're done. This is one way to get x, and that is acceptable as a final answer. Now, if this were a multiple choice question, then it might not appear. Okay, you tried to do it this way, and you look at the choices, and you don't see it. Maybe it was solved another way. Instead of using base 2, base e was used. How will that work? You take ln, and remember, you can bring down the exponent. And so you have x also in terms of base e. There. This is also correct. In fact, if you are required to use base e all the time, then this is the approach that you have to take. Okay, is there any questions so far before I show you another approach? I assume there's none. So how are we going to solve this in another way without having to use a transformation? You can do this directly by manipulating the equation right away. Cross multiply. Let me just show it step by step. Then you distribute. Then you solve for x. Since you're going to solve for x, you collect all those terms containing x on one side. Those without x, collect them on the other side. And then you're going to factor out those terms containing x. You factor out 2 to the x, you have y and 1. So now you get 2 to the x equals y plus 1 over y minus 1. And notice this is just the same one, okay, we had after using the conversion. Okay, we solved for t, then we reverted back to 2 to the x. This is what we got as well. And from here, you just have to do the same. Either you take base 2, take this to base 2, or to the natural base t. In high school, you would be using base 10 to solve this. But here, since this is college, you will be required to use either the base naturally or the bases that appear in the equation or the natural base. Any question? Otherwise, we move on to exponential growth and decay. I actually only plan to spend 30 minutes, okay, today. Kung kaya, 30 to 45 minutes. And then we'll have trigonometry next week. I actually deleted, by the way, graded exercise 3, since there were errors in the questions. Some do not have, okay, questions. Actually, they are blank questions. and some of the questions have incorrect answers. So I had to delete and then recopy and edit those parts. But I believe only a few have taken the graded exercise, so that won't be much of a problem. Anyway, it's better if you prepare well for the graded exercise, worth 6.3% of your grade. Actually, I did not change the questions. I just changed the wrong answers. Okay. Only one, I think, item had a wrong answer. Perhaps a typo. I just changed something to this number. Okay. Next. Here, actually, this is an example in the module. So let me discuss it online as well. So we are given here the function which is exponential, and of course we expect the formulas to be given.
Sir, you're muffled po again.
I'm choppy.
Hindi ka po lang namin narinig. Humina lang po.
Okay, baka I need to use the. Let me try the laptop. Let me try to disconnect from my tablet. Okay.
Okay
But,
naman po ngayon, sir.
okay naman.
Opo, siguro po, yung mic niyo po siguro lumalayo or something.
So, by mic dito siguro sa baba ng screen. Okay, anyway. So you expect the formula not only to be given, but to be in exponential form. And usually it's like CE to the KT. Okay. Otherwise, it's no longer a problem on exponential growth or decay. So the thing with exponential growth and decay problems is to actually find the missing values in the given formula. If not given, okay, right away, or every detail in the formula is given right away. Like in this one, you see that C is not given, and sometimes both K and C will not be given. So you will have to deduce them from the given in the problem. But here we're given K, so no problem with that. We just have to find C. Okay, let me just rewrite that. So this is the function that models bacterial growth, where T is time in minutes, and this is the number of bacteria present at that time, T. So you have to find C, although the question is how many minutes will the bacteria be 10,000? Actually, there's first question given. If 5,000 bacteria are present after 10 minutes, how many were present initially? So you need to solve for C. And actually C is, just take note of this if you have not read the modules yet or watched the asynchronous videos. C is actually always the initial condition. Meaning when time is 0 at the beginning. So this would be, in this case, the initial population or bacteria population. If this were a substance, this would be the weight or the mass or whatever, the volume, okay, of the substance at the beginning, time 0, T equals 0. But we are not given the initial condition, but sometimes it will be. So if it's said there, say 2,000 bacteria are present initially, actually all you have to do is write that as 2,000. And there's an explanation to that. Because if you denote time Okay, if you generalize this one, if you let t be equal 0 in an exponential function, what happens? F of 0, which is the initial condition, would be CE to the k times 0, which is CE to the 0, and CE to the 0, e to the 0 is 1. So what does that tell you? C is the initial value at time t equals 0. So if you are given 2,000 is the initial population, then you put 2,000 right away for C there. Okay, but here it's not given. You're given a certain number after a certain time, 10 minutes, 5,000 bacteria. So we will have to solve for C first before we can solve the questions, answer the questions there. So how do we do so? Well, we take note of that 5,000 bacteria present after 10 minutes. So what does that mean? When T is 10 minutes, population is 10. Sorry, population is 5,000. Okay. 10 minutes would be for your time T. 5,000 would be for your function value at that time T, or 10. So we can use this to solve for C in this one. So if we plug in those values, we will get the following equation: 5,000 equals C E to the 0.035 times 10. And then you can solve for C by dividing both sides of the equation by this number. You can just simplify 0.035 times 10 as 0.35. And you can use your calculator to round this off to, since we are not that strict with the approximation, so we will allow approximation right away, although it should not really be if we want to get a very precise answer. But as I have said, I will allow you to approximate right away if you're solving first for a certain constant or any unknown in the problem before you actually solve for what's being asked in the problem. So we'll round this off, and please use your calculator to verify. Let me get mine. Okay, you should be familiar with the use of your calculator. I see my E here as on top of my LN button, so I have to use shift, or for some second F for function. Okay, so shift LN, and then I input 0.35. 3,523.440, so to two decimal places, 0.44. There, we got C. And so we can write the function now as f of t equals 3,523.44 e to the 0.035 t. Okay. So we have the function now, and therefore we can answer the questions now. How many were present initially? Well, we've already answered that. We can find the answer in the function. It's this one here. Okay, we got C. In fact, when you say initially, it's t equals 0, just to assure you or confirm that it's C, you can plug in 0 here. And what happens to this one? It's 0. Anything raised to 0 is 1. So times 1, that's the initial number of bacteria. But since this is population, we have to round it off to the nearest. I think we should round down instead of round off. Why? Well, this means that, okay, the next bacteria is not yet fully formed. Okay, kahit na ang sagot mo ay 3,523.9, you do not say there were 3,524 bacteria initially, because 0.9 technically is not a bacteria. I mean, there's no such thing like half a bacteria or 9/10 of a bacteria, right? So let's say that's still in the process of what they call this what do you call that process wherein bacteria multiplies? Is there a term for that? Kasi kapag sa cell division, di ba? Anong tawag doon? Anyway, so your answer should be 3,523. But don't worry, hindi naman ganun akong ka-strict. Kung sakali no na 3,524, well, I might consider that or just deduct a very small point. Kasi expected naman marunong tayong mag-round off, but as I have said, you should round down even if it's 0.9, since you're speaking of population here. But that would be your answer. This should be your answer for the first question, or if it's item A, you answer that, not 0.44. Don't include the 0.44, okay? But when you compute, or you answer the next questions, if there is any other question, like in this one, after how many minutes will the bacteria be 10,000? So you have to use this 0.44 now, since a little change might affect the final answer and the difference might be considerable. So you might get surprised when, did I get wrong here? I've tried my calculator many times. But my answer is quite near, but quite is not good enough, right? So it has to be precise. But anyway, you're being asked for how many minutes will the bacteria be 10,000? In other words, when is f of t equal to 10,000? You're going to solve for time using the function now. So you put 10,000 for f of t and solve for t. And how do you solve for t? You isolate the term containing t on one side, so divide by this number. And then you can approximate, as I have said, each time to 2 decimal places, or if specified, you can use the specified, okay, number of decimals. But if you want to have a more precise answer or approximation or approximations each time, you can use more, like 4 would be good enough, so that if you round off to 2 decimal places, then you know that it's precise, since you're using 4 in the first place. So that when you round off or round down, round up to 2 decimals, then you're sure you have a good answer there. But I round this off to 2. So I have okay. Let me stand corrected. Okay, stand corrected here. If I try to do so, okay, I'll get 2.84. Okay, let me explain. Sorry. Ang mangyayari kasi, mag-ln pa tayo, no? Now, if I want a precise answer, this is what I'll be doing actually. Pag hindi ko napansin na nandun pa lang pala tayo. So e to the point, if you take the ln of both sides, I won't touch this yet. Take the ln of both sides. So I also ln the right-hand side. Now, let me just say that this becomes 0.035t, right? So if I take the ln of both sides, what happens is this. So instead of touching or right away evaluating that number and then reducing it or rounding it off, which will affect the precision of the values. So I'll solve for t as some expression first. And then that's when I round off to the required number of decimal places. There. Now notice that if you round this off to 2 and then you take the ln and then you round off again and then you divide by 0.035 and then you round off, then the error would like actually cube. Actually, it will cube since you're multiplying them all. Though it's a small error at first, but it accumulates each time you round off. So if you want to just be sure, okay, either you round off to a lot of decimal places like 4, as I have said, or more, or if you are able, write the solution or the answer as an expression, and then that's when you use your calculator and then round off the final answer. So I'll use my calculator now. So I press ln first. Well, I don't have a scientific calculator here. I only have an app. So it's scientific, okay, calculator app. So, well, it appears on the screen though. So I can rearrange, edit the screen to get what I want. Okay, and then, sorry, I have to make it things wrong. 29.804, so 29.80 to 2 decimal places. 29.8 minutes. You can just check the module. Actually, it's already explained there. But it's different, of course, when we're discussing it live or online. Kasi nung face-to-face classes, you'll really see the equations evolving on the board. So I chose to use a tablet wherein I write the answers. So it's like discussing, okay, in class, and you're seeing what's happening as we go along solving a certain problem or theorem, concept, application, illustration, example. Okay? Kasi lahat naman ng videos natin, yun din yung i-discuss ko. Kung i-asynchronous ko yon, we will lack time. So I've decided to just upload my previous videos wherein I used PowerPoint. And then ang problema sa PowerPoint, minsan mahirap sundan. Kasi naka-type na lahat, i-click ko na lang, lalabas na yung susunod na equation, naka-prepared na kasi lahat. And then kapag may error along the way, hindi ko na ma-edit, di ba? So, it's better this way, I think. Hanggang online pa, no? Iba pa rin kasi pag face-to-face. Pag face-to-face talagang very formal, we will have to discuss all the concepts, all the theorems, all the axioms, all the concepts, and then problems talaga, kaya ang tagal matapos. So just bear with me kasi talagang online tayo. Then yung connection pa pag problema, di ba? Is there any question regarding the first problem on exponential growth? So I think that should be enough for today, if that's okay with you, unless somebody would like to ask a question or you want me to do this now. I plan to do this in the next class and then upload later. You can find this in the module, though. You can read on it, study it on your own. Who has a question? Okay naman, hindi ako nag-lag, except the volume siguro.
Yes po, okay naman po.
Okay. I usually go once a week to the province, then go back. So that depends. Pag nasa Manila, mas mabilis. So pag dito, medyo adjust tayo ng konti. Okay, so that's it for today.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Hi sir, I have a question
Dito
po.
pa pala.
Sorry,
Okay.
sorry po, I didn't get to habol it. When I looked at the example for exponential growth and decay, the second one po, the one you were going to
Discuss
present.
ngayon, ano? Okay.
Yes, sir.
Yan natin.
I noticed po, I think,
This one or the previous one?
that one po, the one regarding the radioactive substance po. Opo,
Okay,
yun
okay.
po.
Sige, sige.
What I noticed po in the discussion or the given one in the module.
Nabasa mo na ito, ano?
Yes po. For the solution po, for when 10 is equal to 10, the equation was y
Yes.
equals...
There was a typo error.
It's a typo po.
Was supposed to have been given. Di ba may value lumabas doon?
Yes
Tingnan
po.
natin siya.
Yeah, there's a value po. It's negative 0.002.
Ayun, given talaga yun.
Opo, given na po.
Oo,
Pero
yun.
my
Kaya-
question was po, when it got to 10 equals 10, how come it was changed to negative 0.02 lang
So
po?
K is?
K is negative 0.002.
Oo, kasi supposedly wala yung negative na yun. Nakalagay na yung negative. So dapat ang given, CE to the negative 0.00 what again?
002 po.
Yan lang, sakto?
Yes.
Ayan, yan siya talaga.
Yes, sir. Pero when it got to like the solution po for when t is equal to 10, supposedly once we, like since we already have y, that's 500. So if we put the equation, it would be y equals 500.
Tingnan nga natin muna. Where's
Yes
the
po.
exponential growth ng K? So, yun. Ayun.
Where's that?
Right?
There po,
Ito yun,
in the line for when 10 is equal to 10, shouldn't it be negative 0.002 po? Parang kulang po siya ng isang zero.
Some part dito?
Sa number 1 po, when t is equal to 10.
Okay. So, naging typo error, ano?
So,
It's a typo.
okay po. I got scared. I thought I solved it wrong.
Anyway, I'll be discussing this in the next class naman.
Okay po.
I-upload ko. Okay.
Okay, thank you so much, sir. Sorry for taking
Welcome.
your time po.
No
Thank
problem.
you. Have a nice day po.